Today we'll be looking at two more systems of equations, except they'll be in three variables. So let's say we've got the following equations. Equation A is 2x plus y plus z equals 3. Equation B is 3x minus 2y minus 3z equals 17. And equation C is 2x plus 2y minus z equals 6. When you're working with a system with three variables, x, y, and z, you're now in three-dimensional space. So you're going to have your x being left and right still, your y is still going to be up and down, but your z is now going to give you depth to your graph. And what we're solving for is still, when do these three equations, which are just lines in this three-dimensional space, when are they going to intersect? At that intersection, they will have the exact same x, the exact same y, and the exact same z. So here's how you'll do this. You're going to pick a variable that you want to eliminate first. So when I look at these equations, I see a z and a negative z. I can eliminate these z's by taking equations A and C and then adding them together. And that's exactly what you want to do. You want to pick a variable and then pick two equations and then get rid of that variable. Eliminate that variable with those two equations and then do the exact same thing with a different combination of two equations. Let's start with A and C. Let's write them over here. I'm going to write them exactly as I see them. So this will be 2x plus y plus z equals 3. And this will be 2x plus 2y minus z equals 6. And I see that they're opposite signs. So I'm going to go ahead and add these. This will give 2x plus 2x is 4x. Y plus 2y is 3y. Equals 3 plus 6 is 9. Now this is a brand new equation that I've created, and so I'm going to give it a new label. I've already used labels A, B, and C, so let's call this equation D. And I'm going to highlight it so it's easier to find later. All right, now what I'm going to do is I'm going to pick a different combination. I've already used A and C to eliminate Z, so I want to pick a different combination. I can pick A and B, I can pick B and C, I just can't do A and C together again. So let's just do A and B. If I were to eliminate Z with A and B, I would need to multiply A by 3 in order to get 3Z. So we'll do that down here. That's 3a, and then b. This means multiply everything in a by 3. So this will be 6x plus 3y plus 3z equals 9. And then b is exactly as it is. 3x minus 2y minus 3z. This is equal to 17. All right, opposite signs, so let's add. Six x plus 3x will be 9x. 3y plus negative 2y, so that'll be a single y. And this is equal to 9 plus 17 is 26. Again, I've created a new equation, so I'm going to give it a new label. I've used A, B, C, D, so I'm going to call this E. And let's highlight this. All right, now look at just the highlighted equations. 4x plus 3y equals 9, and 9x plus y equals 26. If I ignore everything else on that page except for these two highlighted equations, this looks exactly like all the other problems that we've done. we can use substitution or elimination method to solve for one of the variables and then plug back in to find the other one. So let's do that. I've got D and E. Let's eliminate maybe Y, and we'll multiply E by 3 in order to match with this 3Y and D. So I'll have D here, and then 3E. D is 4x plus 3y is equal to 9, and 3 times E. So everything in E multiplied by 3, that'll be 27x plus 3y equals 26 times 3 is 78. These are the same sign, 3y, 3y. Let's subtract. So 4x minus 27x will be negative 23x. This is equal to 9 minus 78 will be negative 69. And now I can solve for x. So I'll divide both sides by this negative 23. And x is going to be equal to 3. Once you've solved for one of these variables here, x equals 3, you're going to go back a step to your highlighted equations. You're going to pick one of these and plug in x equals 3 in this case. So if I pick equation D, let's write that out here. D is 4x plus 3y equals 9. And I now know x equals 3. So I can say 4 times 3, and then plus 3y equals 9. This is 12, so 12 plus 3y equals 9. We'll subtract 12 from both sides. (3y) equals 9 minus 12 will be negative 3. And then divide both sides by 3. So y will be equal to negative 1. Okay, in this system, x equals 3, y equals negative 1. I just have to find what z is. Once you know 2 of the variables, go back another step to your original equations, pick one of them, and plug in the 2 variables that you've solved already. So I can pick whichever one I think is going to be easiest. I can do a here. That'll be 2x plus y plus z is equal to 3. But I now know that x is 3 and y is negative 1. So this will be 2 times x is 3 plus y is negative 1 plus z is equal to 3. 6 minus 1 plus z is equal to 3. 5 plus z is equal to 3. And then subtracting 5 from both sides. Z is equal to 3 minus 5 is negative 2. This is your solution. X equals 3, y equals negative 1, z equals negative 2. In three-dimensional space, I know that these 3 lines are going to intersect at the ordered triple 3, negative 1, negative 2. Let's do one more. Now I've got this system. Equation A is x minus y plus z equals 0. Equation B is 3x plus 2y plus 2z equals 21. And C is x minus y minus z equals 2. I'm going to start by picking a variable and let's eliminate those. So let's do the z's, and I'm going to do equation A and C since they're already exactly opposites. So over to the left, we'll say A and C. A is x minus y plus z equals 0. And C is x minus y minus z equals 2. Getting rid of the z's, they're exact opposites. Let's add. Two x minus 2y is equal to 2. And this is a brand new equation. I'm using labels A, B, and C already. We'll call this D. And I'll highlight. Okay, let's eliminate Z again using a different combination. We can do A and B. So if I were to eliminate Z using A and B, I'd multiply by 2 to A. So let's do 2A here and then B. 2A is going to be 2x minus 2y plus 2z is equal to 0. And then B will be 3x plus 2y plus 2z equals 21. Now that the z's are both positive 2, same sign, so we can subtract. (2x minus 3x will be negative x. Negative 2y minus 2y will be negative 4y. And this is equal to 0 minus 21 is negative 21. This is a new equation, so let's call this A, B, C, D. We'll call it E. And we'll highlight it. Now, using the highlighted equations, D and E, I've got two equations with two variables. It's just like the ones that I start with two variables. So I'm going to eliminate one more variable. Let's see. Let's eliminate the y's. So if I multiply D by 2, this will give me negative 4y here to match this negative 4y in E. So that'll be 2D and then E. 2D is 4x minus 4y equals 4. And E is negative x minus 4y is equal to negative 21. These are the same sign, negative 4, negative 4. So same sign, subtract. Now I've got 4x minus negative x, so this will be 5x, equals 4 minus negative 21. It's going to be 25. Go ahead and solve. Divide both sides by 5. X is equal to 5. All right, once you solve for one of the variables, go back to one of the highlighted equations and plug it in. So if I go to equation D, which is 2x minus 2y equals 2, I can plug in x equals 5. 2 times 5 minus 2y is equal to 2. So this will be 10 minus 2y is equal to 2. Subtract 10 from both sides. Negative 2y is equal to 2 minus 10 is negative 8. And lastly, divide by negative 2 here. So this is y equals positive 4. And once you've solved for two of the variables, you're going to go back to your original equations, and you're going to plug both x equals 5 in this case and y equals 4 into one of these. I think a would be the easiest one. So over here, let's just write down a is x minus y plus z is equal to 0. And now we know x is 5 and y is 4. So this will be 5 minus 4 plus z is equal to 0. 5 minus 4 is 1 plus z is equal to 0. And subtract 1. Z equals negative 1. This means in three-dimensional space, these three lines will intersect at the ordered triple 5, 4, negative 1.